Okay, 5.3, investigate transformations of the sine and cosine functions. Okay, so first we're going to touch on vertical and horizontal translations. Okay, so vertical going up and down, horizontal going left and right. So on the graph below, graph one cycle of each of the following by shifting the base graph left and right. Okay, so thinking back to 5.2, we talked about the critical points, okay? So for y equals sine x, we have to know that we plot sine x at 0, 0, 91, 180, 0, 270, negative 1, and 360, 0. Okay, that's always going to be the base graph or the parent function for sine x. Now, if we take a look at y equals sine bracket x plus 30, we know that this is going to go to the left 30 degrees. Okay, left 30 degrees. So we're going to take each one of these, 1, 2, 3, 4, 5 points, and we're going to shift it to the left 30 degrees. Okay, left 30, left 30. Okay, and instead of naming them right on my graph, I'm going to box them so it's going to kind of be a legend for us. Okay, and then y equals sine x minus 60, we're going to go to the right 60 degrees. Okay, and that's from the original. So we start at the blue, and we go to the right 60. Start at the blue, go to the right 60. Right 60, right 60, and right 60. So if we notice, the graph y equals sine x doesn't actually change. In shape, all it does is it shifts to the left and the right when in this position here. Now, number 2, on the graph below, graph one cycle of each of the following by shifting the base graph, okay, left and right. So again, I'm going to plot the base graph. This time we're dealing with y equals cos x. So for cos, we start at 0, 1, 90, 0, 180, negative 1, 270, 0, and then 361. Okay, that's our base graph. Then what we do in the second one is we move this to the left 30 degrees. So the scale is 30 degrees, so we're going to go basically left one box. Just make sure that you're not just counting boxes, you're actually taking a look at the scale. Okay, so all of these 5 critical points, we're moving to the left 30 degrees. Okay, and this one, y equals cos bracket x minus 45. This one is going to the right 45 degrees. So the right 45 is going to actually be like a box and a half. Okay, box and a half. Box and a half, box and a half, box and a half. There we go. Okay, so here's the conclusion down here. When h is greater than 0, the graph of f at x moves to the, this is right, h units, okay? And in brackets, we can say like h looks negative. Remember, there's that built-in negative sign in that bracket. Okay, and when h is less than 0, okay, so this is like when h is negative, but it looks positive. When it is negative, it moves to the left. Okay, and just note the h value is called the phase shift or the phase angle. So you're going to have to know these words right here for questions that come up. Okay, number 3, on the graph below, graph one cycle of each of the following by shifting the base graph up and down. Okay, so this time we're going up and down. So let's start with the base graph of sine x. Okay, 0, 0, 91, 180, negative 180, 0, 270, negative 1, 361. There we go. Okay, so for the second one, what we're going to do is we're going to take our graph and we're going to go up 2. Okay, so each box represents 1 in the vertical direction. So 1, 2, 1, 2, 1, 2, 1, 2, and 1, 2. Okay, and then the last one, y equals sine x minus 3, we're going down 3. Okay, so go to the original, okay, don't start at the green one, go back to the original, which is blue, and go 1, 2, 3, down. 1, 2, 3, down. Okay, and we're shifting each one of these critical points down 3. Number 4, on the graph below, graph one cycle of each of the following by shifting the base graph up and down. Okay, this time we're going to deal with cos. So cos starts at 1, and then every 90 degrees, we're going to zigzag up and down, okay? So 90, 0, 180, negative 1, 270, 0, 360, 1. Okay. For the second one here, we're going to go up 5. So start with the base graph, the 5 critical points, and shift each one up 5. 1, 2, 3, 4, 5. So 1 goes up to 6, 0 goes up to 5. Okay, so again, the curve isn't changing, the shape isn't changing, it's just shifting up or down. Okay, and y equals cos minus 1. So this time we're starting with the base graph and we're going down 1. Okay, and we can just count boxes for this one because the scale is 1. Okay, so here's our conclusion. Okay, just to be consistent with our other notes, I'm going to actually just call this the C value, okay? So when C is greater than 0, the graph of y equals f at x moves up C units. And when a C is less than 0, the graph is going to move down C units. Okay, so this C value is called the equation of axis. In other words, taking a look up here at the graph, I'm going to do it in purple. The equation of axis, black, for the green graph is at x equals 5. The equation of axis for the original graph is at, y equals 5. This one's y equals 0. And the equation of axis for the red graph, okay, and it cuts it horizontally in the middle. That one's y equals negative 1. Okay, and those correspond directly to the C value. And of course, the original is cos x and like plus 0, technically. Okay, now we're going to deal with vertical and horizontal stretches and compressions. Okay, so on the graph below, graph one cycle of each of the following by multiplying each x value of the base graph by a. Okay, now we're going to take a look at vertical and horizontal stretches and compressions. So on the graph below, graph one cycle of each of the following by multiplying each y value of the base graph by a. Okay, so we're going to start with sine. Okay, I always memorize sine like, like the letter S starts or like at the start, okay, being like the origin. In my mind, like the origin's the start. So I always memorize sine as being the one here, and then cos by default starts at 1. Okay, so 0, 0, 91, 180, 270, negative 1, 360. Okay, so here is our base graph. Now, okay, now we have y equals 3 sine x. So what we're going to do is we're going to stretch this up and down. Okay, this is a vertical stretch by a factor of 3. Okay, and we're going to learn very soon that this is also called the amplitude. Okay, it's how big your hump is. So at 90, instead of being at 1, we're going to multiply that by 3, and we have to go up to 3. Okay, 0, remember this is 0, so 0 just stays. Okay, this is negative 1, so we're going to multiply by 3, we get negative 3, and then 0 just stays. Okay, so we'll make a connection in the next section, but since this is 3, our hump is now 3. The original hump right here would be 1. Okay, up and down. Okay, and then the last one, y equals 1/2 sine x. So this is a vertical compression by a factor of 1/2. So what happens is, so the zeros stay the same, 0, 0, 0, okay? But now instead of plotting at 1, we're actually going to plot sine at just 1/2, because it's like 1 times 1/2, and we get 1/2. And instead of plotting at negative 1, we're going to plot at negative 1/2. And that's what we get. Now, 1/2 is going to be our amplitude, which is our hump up. Okay, our hump up and our hump down from our original equation of axis. And remember, the original equation of axis, y equals 0. Okay, which is halfway between the max and the min. Okay, number 6. On the graph below, graph one cycle of each of the following by multiplying each, this is y value, of the base graph by a. Okay, so this time we're doing coast. So coast starts at 1. Okay, goes down to 0 at 90, 180, negative 1, 270, 0, and 361. Okay, now we have a 4 here. Okay, so the amplitude is going to be 4. This is going to be a vertical stretch by a factor of 4. So what happens is, like, this technically is like the top of the hump here, okay? So it was at 1, now it's at 4. Whatever this number is, that's where it's located, okay? The 2x intercepts are going to stay the same. So we're going to go down, and then instead of being at negative 1, it's at negative 4, okay? It's just going to be stretched vertically. Okay, and then instead of being at 1, again, it's at 4. Okay, so our amplitude, our hump, our amplitude is 4. Okay, and then y equals 1/3 cos x. This is a vertical compression by a factor of 1/3. So our hump is going to be 1/3. And it's going to be really hard to connect this, but that's okay. This is 1/3. Well, negative 1/3. Okay, the zeros are at 0, and then that's 1/3. So this hump here is 1/3. Okay, so what's our conclusion here? When A, so we do absolute value. So when we write two brackets like this, but they're straight brackets, this is called absolute value. And what that means is, it means just to look at the A and just take the positive of it, okay? So always positive. Okay, so when that actual A number is greater than 1, the graph of f at x is stretched by a factor of A. Let's be more specific, vertically. Stretched by a factor of A. And when that A is like a fraction, then it's vertically compressed by a factor of A. Just remember, like, we don't care about the sign right now because that sign makes our graph reflect. And we're going to take a look at that separately, okay? And then just note that the A value is also called the amplitude, which is very convenient because they both start with the letter A. Okay, question 7. On the graph below, graph one cycle of each of the following by multiplying the x value of the base graph by 1 over k. Okay, so we're going to start with just sine x. So 0, 0, 90, 1, 180, 0, 270, negative 1, 360, 0. Okay, so this is going to be our base graph. Okay, this time what's happening here is this is a horizontal compression by a factor of 1 over 2, okay? Remember, this looks like a 2, but it's actually the reciprocal of whatever number this is, so it's 1 over 2. So what we're going to do is we are going, sorry, I'm going to box this in green, okay? We're going to take every single x value and we're going to half it. So basically, right now, the period of the blue graph, okay, it goes from 0 to 360. So what is going to happen is we're going to half that. So we're going to have an entire rotation between 0 and 180, which is half of that. Okay, so the first point 0, 0 is just going to stay. 90 is going to go in half to 45. Okay, and just note this is 30, 60. Okay, every box is going up by 30s. Okay, 180 is going to half to 90. 270 is going to half to 135. And you're going to get really familiar with these numbers. 360 is going to half to 180. Okay, so this one, same amplitude, doesn't shift over, it starts at the 0, 0. The only thing is that kind of like an accordion, it's going to have that horizontal compression. It's every point is actually getting closer to the y-axis. Okay. Now, y equals sine 1/3 x. This is actually a horizontal stretch by a factor of 3. Remember, it's a factor of whatever the reciprocal of like the 1 over 3 is. So 0, 0 stays just because it's zeros. Okay. From the original, we had 90. And now what we're going to have is 90 times 3. So instead of plotting it here, it's going to be plotted at 270. So it's going to be stretched. Okay. And instead of plotting this point at 180, we're going to plot at 540 because we're stretching it times 3. Every x value is going to be multiplied by 3. And then we're going to do 270 times 3. I get 810. And then I'm going to get 360 times 3. I get 1080. Okay, so it's taking longer. The period is longer. Taking longer to get through one cycle. Okay, on the graph below, graph one cycle of each of the following by multiplying the x value by 1 over k. Okay, so the original one is cos x. I'm going to start at 1, and then 90, 0, 180, negative 1, 270, and 360. Okay, just oscillating between the 1, the 0, and the negative 1. Okay, y equals cos 3x. So this is actually a horizontal compression by a factor of 1 over 3. okay? It's the reciprocal of 3, so 1 over 3. We're going to take every single x value, so every single number on these values here, and we're going to divide it by 3. So the first one stays as it is because we're actually plotted at 0. 90 divided by 3 is 30. 180 divided by 3 is 60. Okay, 270 divided by 3, I'm just double checking. $90, and I'm assuming that's 120. Okay, so we took the period of being originally 360 and we cut it into 3. So essentially what's happening here is there are going to be 3 up and downs within where one period should have been, right, of the original. Okay, and the last one, this one is going to be a horizontal stretch by a factor of 2. Okay, so let's double everything. So this one stays because it's 0. And then 90 doubles to 180. 180 doubles to 360. Okay, 270 doubles to 540. And 360 doubles to 720. Okay, I just want to quickly show this. So the original is blue. If I keep graphing just by patterning, oops. Okay, if I keep graphing by patterning here, and we take a look at this green, if you can see, in 360 degrees, green rotates 1, 2, 3 times. Okay, hence, when we're taking a look at the equation, it's compressed by 1/3. So again, in 360 degrees, where there would usually be 1 rotation of cos, there's now 3 rotations of cos. And just to be consistent, we're calling this k. And this is going to come back the k value. Okay, when k is greater than 1, the graph is horizontally. This is going to be compressed by, technically it's 1 over k, and when k is a fraction, so between 0 and 1, it's going to be horizontally stretched by a factor of 1 over k. Okay, and note the k value is used to calculate the period. Okay, so the k value actually doesn't mean anything much, but we have period equals 360 divided by that actual k value. And we can use that k value to solve for the period, and we can use the period to solve for the k value. Okay, reflections. On the graph below, graph one cycle of each of the following by reflecting the base graph over the x-axis, okay? So our original is sine, 0, 90, 180, 270, 360. Those numbers are going to be ingrained in you, okay? Now, we're going to reflect it. So I'm going to be honest. 0 doesn't reflect, okay? So if we're looking at these y values here, right? Because when we're reflecting over the x-axis either way, we're affecting these y values. So 0 is not affected by a reflection. It's still going to be an x-intercept, okay? But this 1 is now reflected to -1. Okay, and then this -1 is reflected up to 1. do that again. There we go. Okay, and that is the graph y equals negative sine x. Okay, number 10. On the graph below, graph one cycle of each of the following by reflecting the base graph over the x-axis. Okay, this time we're dealing with cos. So at 0, 90, 180, 270, 360. Okay, so this is our cos graph. Now, negative cos x. What we're going to do is we're going to reflect, because this is negative, we're going to reflect the 1, and it's going to go to negative 1. Okay, the two x-intercepts are the same, so those don't change. And we're going to reflect this negative 1 to 1. And we're going to reflect this 1 to negative 1. Okay, and that's it. So let's just write a conclusion. When a is less than 0, in other words, if it's negative, the graph f at x is reflected in the x-axis. Okay, and then just to know, the graph cos x, the original graph of cos looks like this, okay? So it starts at a maximum, goes to a minimum, and back to a maximum. Well, now with the reflection, so with the reflection, what happens is it starts at now a minimum, and it goes up to a maximum and back down to a minimum. Okay, so it starts at a minimum and increases first. Okay, now I'll do this one in blue. So when we look at sine starts on the equation of axis, which is in the middle, and then increases first. It goes up to a maximum first. When sine is reflected, it actually goes down to a minimum first. Okay, but it still starts at the equation of axis.